Hello everyone. In this video, we are going to see an advanced concept in Java called data structures. Data structure is a way to store and organize data so that it can be used efficiently. So it is a concept where you can store all the data in the memory in organized manner so that you can utilize the data very efficiently. So here you got some various data structures available. First one is very popular, that is arrays, which you already learned in the previous sections. And the new topics, that is new concept in data structures are like linked list, stack, queue, tree and graph. So we are going to see about linked list, stack and queue in this video. And tree and graph are the advanced concept of data structures. The first concept we are going to see is linked list. The term list refers to a linear collection of data. So once if you say a word list, it's nothing but collection of data. So it is a linear collection of data. One form of linear list are arrays. So normally you would have seen single dimensional array where you will have a sequential list of elements available. It will be in the sequential order. Okay. Same way, a linear relationship between the data elements of the array is reflected by the physical relationship of the data in the memory. That means if you store the data in the memory, it will be stored in sequential order, that is sequential allocation. That means the address will be, for example, if the address of the first element is 101, the next element may be 102, so it will be in a sequential order. So once you know the address of the first element, then it is easy to retrieve all the elements in the arrays. Data element does not contain any information by them. That is another one disadvantage in arrays is it does not have any information by themselves. Only the first address will be known automatically. It will connect to the remaining elements. Now in linked list, is again it's a linear collection of data elements, and here you are going to use a concept called nodes. So node is nothing but it has two parts. Okay, so first part has the information of the element, second part has the address of the next node. So this node can store the information of the data elements pointing to the next node, so that you can call this as an dynamic allocation. So here you are not going to create like arrays where you have maximum of 10 elements or 15 elements or 20 elements. Here you are going to create one by one. That means you can always increase or decrease the linked list size. When you have an array, you will have a fixed memory location. That means if you have maximum of 10, whether you use it or not, you will have maximum 10 memory boxes will be allotted in the in sequential order in the memory. But in linked list you will be creating node by node. So as you increase the elements one by one, the number of nodes also will be increasing. The next concept is stack. A stack is a linear structure, the same like linked list, implemented in LIFO, that is LIFO manner, that is last in first out algorithm. So insertion and deletion are restricted to occur only at one end of the stack top. So you can see stack look like this. Okay, like a vessel where you can have all the numbers stored. It will be similar to the arrays. Only difference is the stack can insert or delete only at the one end, that is on the top. So the insertion process are called as push and the deletion process called as pop. And this LIFO means elements last inserted will be the first one to be deleted. So it's like keeping the plates one above the other one. So the last plate you keep will be the first plate to be taken out. Same way when you submit your records for correction, the person who submit the record last will be the first person to take it back after correction. So that is the logic used in stack, last in first out. It is a dynamic data structure as it can grow or shrink. That means it can always increases its memory, that is location, that is elements, or you can decrease the elements. So it is dynamic allocation. Next concept is queue. A queue is a linear dynamic structure. Again these three are linear dynamic structures like linked list, stack and queue, implemented in another algorithm called FIFO, first in first out manner. Normally queue is a normal word used where you are going to stand in a queue The first person goes inside the queue will be the first person will be coming out of the queue. The same concept is used here. The insertion can occur at the rear end, deletion can occur at the front end. You can see here, insertion will be from the back and deletion from the front. So unlike stack, here you got both sides are open, and once you insert, slowly the elements will be moved towards front, and once you delete it, you can see that data will be moved in front. The FIFO means elements are deleted in the same order as they inserted into. As you see in the queue, normally the first person who goes in front will be the first person will be coming out of the queue. Same way here, the numbers will be inserted from the rear end. The same order it will come out. Now, it is not like stack. It is using FIFO concept. Hope you understood these concept about data structures. We will be discussing more about stack, queue and linked list in future videos along with the programs. Till then, thank you.